In this video, we are going to look at our learning target that has to do with percent yield. So we're going to learn how to calculate a percent yield from the theoretical yield and a given actual yield. So you need to know what those terms mean, and those are part of your vocab words, actual and theoretical, and then know the formula and how to use it. Now this is one formula that is not on your reference packet. Just keep that in mind, so you will need to know it. Alright, so what is a percent yield? That's the amount of product that's actually formed in the lab, and we're going to compare it to the theoretical amount calculated. So it's basically an efficiency. How effective was your method in the laboratory? So what's the theoretical yield? Where do you find it? The theoretical yield is the amount that would be produced if there were no error involved at all, the amount that would be produced in a perfect world. And we get that from stoichiometry. That's that's the amount that we are calculating mathematically. So the actual yield is what you produce in the experiment. Now, because we can't just get up and go over to the lab and do an experiment, you have to be given this information in the problem. So you'll either be given the actual yield, or sometimes you might be given a percent and asked to find that. So the theoretical yield is what you calculate from stoichiometry. The actual yield will be in the problem. So here's the formula. Percent yield is equal to your actual yield divided by your theoretical yield times 100. Now, majority of the time your actual yield is going to be smaller than your theoretical yield because there's always some error involved. Alright, so typically it's going to be your smaller number over your bigger number. And then don't forget to multiply by 100 to make it a percent. So if we look at an example problem, if the theoretical yield for a reaction is calculated to be 14.8 grams and 9.25 grams were obtained in lab, what is the percent yield? Alright, so I'm underlining and circling the way I'm supposed to. So I need to label these. Which one of these is my actual yield and which one is my theoretical yield? Alright, remember that the actual yield is what we get in lab. So this word obtained in lab here tells me that I got 9.25 grams when I did the experiment. So it says the theoretical amount is calculated to be 14.8 grams. So there, pay attention to the words in the problem. So then we take our formula, so 9.25 divided by 14.8. Don't forget to multiply by 100. So my percent yield is 62.5%. Not a great percent yield, all things considered. Now let's look at another type of problem. Silver bromide was produced by reacting 200 grams of magnesium bromide with excess silver nitrate. Calculate the percent yield, we're trying to find, if 375 grams of silver bromide were produced. Alright, what do we need to do here? We do need to know our actual yield. Alright, so which one of these numbers is what we're producing? So it says if 375 grams of silver bromide were produced. So my actual yield here is 375 grams of silver bromide. So I have 200 grams of magnesium bromide that is reacting with excess silver nitrate. So I could actually write my balanced equation if I know magnesium bromide plus silver nitrate. Alright, this is a double replacement reaction, so we're going to get our magnesium going over here with nitrate. We get MgNO3 2 and our silver bromide plus AgBr. Now this is not balanced. I would have to make sure I balance that. So of course I have that on the next slide for us. So here's our problem broken down. Here's our balanced equation. We have 200 grams of magnesium bromide. We're looking for our theoretical yield of silver bromide. So that's what we're trying to find. So if we're looking at our box, we have moles, molar mass, and grams. Alright, so my moles here is going to be X and 2X. The molar mass for magnesium bromide is 184.11. And the mass of silver bromide is going to be 188. So I get 184.11x, and then multiply that, and we get 376x. So now we need to solve for x. So 200 equals 184. I'm just going to go ahead and round here. So x is going to equal 1.09 moles. So if I do 376 times 1.09, that's going to give me a theoretical yield of 409 grams. Okay, so now I take that theoretical yield and I do my percent yield. Okay, so remember that percent yield is the actual, so that was the amount that they gave to me in the problem, the 375. Oops. So 375 divided by my theoretical, the amount that I calculated from my stoichiometry, of course, times 100, and I get 92% yield, which is a great percent yield if you're doing this in the lab. So actual yield will be given in the problem. Theoretical yield you'll have to calculate from the stoichiometry. Make sure that you know this formula. It is not in the reference packet.